Good morning. All right, we're going to look at section 9.5 trigonometric equations, and again we're using the OpenStax textbook entitled Algebra and Trigonometry. And I'm saying this is part 2 because last week we looked at some examples of trigonometric equations. Let me give you an overview of what that looked like real quick. So we'd have something like this. If we're trying to solve cosine of 1/2, we are trying to find all the values, all the angles, such that when I take cosine of that angle, I get the value 1/2. Okay, now what we could do is use cosine inverse, but if we use cosine inverse, it only gives me the first quadrant solution to this equation, but that's a start. Okay, so we use that first quadrant solution here, this pi/3. That's kind of our reference angle. And remember, cosine's got cosine's positive in the first and the fourth quadrant, so we use pi/3 as our first quadrant reference angle, and then as our fourth quadrant reference angle, we got 5 pi/3. But then remember, if we keep just adding multiples of 2 pi, cosine will repeat itself. And so that's why we say plus 2 pi k, k being an integer. All right. Now, most of the time, we restrict. So let's see, let's go down another example here. Example 3, we restrict our angle from like 0 to 2 pi. So we don't worry about the plus 2 pi k. We're just talking about, yeah, those are solutions, but we're really only talking about, with the first revolution, what are our solutions? And so, for example, this one, 2 cosine theta minus 3 equals -5. And what we said is, look, it's very often a valuable thing to let's let y be cosine theta, and then we can make this into an algebra equation. And so that's what I did. I said y equals cosine theta, then I just solved for y, and then I popped back into, so from here to here, I said y is -1, and now let's go back to saying that's cosine equals -1. When does cosine equal -1? Only at the value pi. Okay, that's the only time. All right, that's kind of what we've done so far, and we've had some variations on that. Example 5, for example. Let's pick up with this one, and then we'll start some new stuff. Examples 6 onward. All right, so here I want to solve cosecant equals -2, and I'm restricting 0 to 4 pi. So I'm looking at the first the first 2 revolutions of my angle. And I'm not too familiar with cosecant, but I can use my identities to go from cosecant to sine. So I say that cosecant, so here I said cosecant is -2. That means that 1 over sine theta equals 1/2, is -2, right? So then I take the reciprocal of both sides. Sine theta equals -1/2. Now that's something I can figure out because I know sine theta, so if you see here in the yellow over here, sine theta equals 1/2 means that theta equals pi/6. Okay, that's my first quadrant angle. When do I have a negative sine value? I have a negative sine value in the third and the fourth quadrant. So that's why over here, I figured out if I had in the quadrant 3, I'm at 7 pi/6. In quadrant 4, I'm at 11 pi/6. But then I remember that's only in the first revolution. What about in the second revolution? Well, I'll just add 2 pi to both of those. And so I end up with these 4 solutions, 7, 11, 19, and 23 pi/6. All right, so those are my 4 solutions to this equation. I hope that makes sense so far. Okay, now we're going to look at a few more complicated examples, but they follow the same format as this, the same idea. And I hope it makes sense. Let me know if you have questions. All right, so let's go back to the top. Okay, and I'm going to look at example 6 from the text, and it asks for us to do this. Solve tangent of theta minus pi/2 equals 1. And here we're restricting ourselves to the first revolution, 0 to 2 pi. Okay, now this is a little interesting because we're not solving exactly for theta right off the bat. We're having to solve for theta minus pi/2. So how can I do that? Why don't we just we used this algebra technique earlier where we let like y equal a tangent value or something. So why don't we let's pick a different angle. How about alpha? Let's let alpha be pi minus 1/2. Okay? And then what I'm looking for, let's solve tangent alpha equals 1, right? So I replaced the the theta minus pi over half with a variable. So now I have tangent theta instead of tangent of that other expression. And the reason I did that is because I think I can figure out when tangent alpha equals 1. That happens when alpha equals, let me think, when does tangent equal 1? At pi over 4, right? Now that's first quadrant. That's first quadrant. So here, first quadrant, I have pi over 4, but tangent's also positive in the third quadrant. So I have something down here as well. How do I have a pi over 4 reference angle in the third quadrant? Well, I just need to add pi to that, right? So I can also have 5 pi over 4. I take pi over 4 and add 4 pi over 4, and that's how I get 5 pi over 4. All right, now, the thing is, we're not solving for alpha, right? We are solving for theta. And so remember, that means we have theta minus pi over 2 equals these two things. And let me set it up as two different equations because that's a little bit more precise. And now I've got to solve these two equations, okay? And so the way I do that is simply, they're linear equations, just add pi over 2 to both sides. But pi over 2, remember, is 2 pi over 4. So I have 2 pi over 4 plus pi over 4. My first solution is 3 pi over 4. The second one, I get theta equals 2 pi over 4 plus 5 pi over 4. My second solution is 7 pi over 4. Okay, so those are my solutions. Why don't we write them together just so we're happy about it. We get 3 pi over 4 and 7 pi over 4. And those are the only ones, right? Because I'm staying between 0 and 2 pi. And these values are the ones that satisfy this equation from 0 to 2 pi. I hope that makes sense. Now what we did here is once we got to tangent alpha equals 1, we were just doing examples like we've already done. The only thing we had to do differently was at the beginning changing our input in the tangent function through this variable. We went from theta to alpha to make the equation easier, and then at the end we went back to theta. Right? And it's kind of the same idea we did in example 5 by letting, or even, let's see, example 3 where we let y equal cosine theta. Okay? Alright, so let's try some more, and hopefully these are making sense to us. Okay, so this time we want to solve. This is example 7 in the text, and I want to solve 2 tangent. Oh, let's be careful in the way we write this. Parentheses matter, right? 2 tangent x plus 3 equals 5 plus tangent x. And here we are, again, restricting ourselves 0 to 2 pi. Oops, and our angle is not theta this time, it's x, right? So we're going from 0 to 2 pi. Okay, so I want to solve 2 times tangent x plus 3 equals 5 plus tangent x. Alright, now, again, I think it's easiest if we let y be our trig value here, our trig function. Let's let y equal tangent x. The reason I like that now is because I have this equation. 2y plus 3 equals 5 plus y. And that is a linear equation. This is strictly algebraic at this point. And so we just need to apply algebra. And hopefully it's not too bad. Let's see, we get 2y plus 6 equals 5 plus y, right? You had to distribute the y in the 2, right? And now we get the y by itself, everything else on the other side. So let's see, subtracting y from both sides, I end up with 1y equals subtracting 6 from both sides, 1y equals -1. So now when I'm solving positive 1, I mean, we just talked about that. I know that using arctan or tan inverse, it's best just to know it, to know the table. And so now I'm thinking, okay, if I have a pi over 4 reference angle, that gives me tangent equals +1. What about -1? When is tangent negative? Tangent is negative in quadrants 2 and quadrant 4. So I have a pi over 4 reference angle in quadrant 2 and quadrant 4. So that means I know my solution is going to be x equals, let's see, in quadrant 2, you find that by saying pi minus pi over 4. And in quadrant 4, you say that by 2 pi minus pi over 4. So we solve these, we get our solutions. So pi is the same as 4 pi over 4, so we get x equals 3 pi over 4, and is that 7 pi over 4? I believe that's correct, right? Because 2 pi, if you need to, 2 pi is the same as 8 pi over 4 minus 1 pi over 4. It gives you the 7 pi over 4, and there are two solutions. And we were restricting, we were restricting ourselves to 0 to 2 pi, so that is good. That's good for us. I hope that makes sense. Please, again, if you have questions on this, let me know, okay? Good. I want to look at a couple more questions. One, we're going to use the calculator, all right? And then the second one, we're just going to, well, let's just see, okay? So this is example, and before I move on, let me point out that the value of this example here, what's very helpful is this transformation, y equals tangent x, because we're taking what looks like a complicated trig equation and we're turning it into an algebraic equation. Now we could easily have done this for a quadratic situation, and let's see if we have time. I might do one of those, okay? So let's look at example 8. In the text, it says we want to solve sine theta equals 0.8. All right, and here it says theta in radians. All right, and we've done all of our solutions in radians already. Okay, now the reason it mentions that though is because to do this question, we're going to need a calculator. We're going to have to use a calculator. Okay, so why do I say that? Because I don't know 0.8, that's like 4/5 or 8/10. That's not a common fraction involved with trig functions. In other words, sine of what common angle gives you 0.8? I don't know that one. All right, so we're going to use sine inverse. So here we're going to say sine inverse of 0.8, which gives me the value, and you need to practice this in your calculator, 0.9273. Okay, 9273. All right, now that is, if you want it in degrees, which we want it in radians, that's in radians, but just to kind of help us, we feel a little more comfortable with degree measures, that means that theta is approximately, converting 0.9273 into degrees, we get 53.1 degrees. Okay, so that is definitely a first quadrant answer, and we knew it needed to be a first quadrant answer because sine inverse of a positive number is going to give me a first quadrant answer. Okay, now the thing is, I need to know, that's not the only solution, right? This is my quadrant 1 solution. Sine is positive in quadrants 1. So in quadrant 1, let me change my color. In quadrant 1, I have this 0.9273 reference angle, I also have a quadrant 2 solution with that same reference angle. I'll call it theta. And so to get my second solution, I need to figure out the quadrant 2 reference angle. So quadrant 1, again, we have the theta is approximately 0.9273, and we wanted radians, right? And then in quadrant 2, my theta value would be, how do you find your angle in quadrant 2? You say pi minus your reference angle. So that's going to be pi minus 0.9273. Again, we're going to use a calculator here. And we should get, I don't have the solution. Let me figure it out real quick. And I'll show you how I'm going to do this. There are a couple ways we can do it. I'm going to go to Wolfram Cloud. So this is Wolfram Cloud here. And a lot of the calculations that Siri comes up with is from Wolfram. So it's a pretty neat thing. Wolfram Cloud, you can set up a free account and you can open up Mathematica notebooks, which if you're going to take higher level mathematics is a very useful thing to have. Okay, now this is way more powerful than we need, but we need to calculate this. We need this calculation. So what I'm going to say here is pi, capital Pi, pi. Let me zoom in a little bit. So capital Pi, pi minus 0.9273. And then to calculate, you hold shift and press enter. And there I get it. That's approximately 2.21429. Okay, we'll keep that in mind. All right, let's go back to our notes. And you can see here I have already written down our solution. Wolfram Alpha is a great thing to keep in your back pocket, but my two solutions then are the 0.9273 and the 2.21429. And technically we need to say plus 2 pi k, with k being an integer value, right? Because we never specified that we only meant 0 to 2 pi, right? If we did, those two answers would be all we needed, but they didn't specify, so we need to include the plus 2 pi k, because every revolution we're going to repeat ourselves. Alright, great. Let's try one more with a calculator. Maybe we'll use Wolfram Cloud again. So this is example 9. I'll get back to my green. And this time I want to solve secant theta equals -4. Okay, secant theta equals -4. Now, most of the time when we have secant, cotangent, or cosecant, we are wanting to use our identities to get back to cosine, tangent, and sine. Okay, so for example, in this one, I don't want to address the answer the equation secant theta equals -4 because I don't know that much about it. But now, instead of I use cosine inverse or arc cosine of -1/4, that's going to be my theta, and that will be approximately 1.8235. Okay, now what quadrant is this in? So we could convert it back to degrees to figure it out, but we remember cosine inverse only comes from quadrants 1 and 2. So if I have a negative cosine value, that's going to be my quadrant 2 angle. So this is what we have found so far. Okay, now the thing is though, cosine is also negative in the quadrant 3. So I need to figure out my reference angle here so that I can find my quadrant 3 angle. Okay, so let's first say, look, we're going to try to find a reference angle. And my reference angle is going to be, well, look at the picture. So there's my reference angle. I know theta right there is a quadrant 2 angle. So my reference angle, which I'll call theta prime, is going to be pi minus that value of theta. So that's going to be pi minus 1.8235. That's approximately. Okay. And let's see. Let's jump on to Cloud to figure out that solution. And before we do that, let's also keep in mind then that my quadrant 3 angle is going to be, so we also need pi plus whatever that reference angle we're about to find is. Okay, so let's keep both of those things in mind. All right, so let me jump on the Cloud again. And we're going to calculate, what did we say? All right, we wanted to calculate, well, let me show you the how you can find arc cosine of negative 1/4. Now the decimal approximation may be a little bit different. Yeah, mathematics is a little too smart for us. We want the numeric value, we want the decimal value of that function. And there I get 1.82348, which is one decimal. We had 1.8235. Okay, so we're going to stick with that. So we're going to say pi minus 1. Okay, I think I'm back. We lost it for a little bit there. Sorry about that. Okay, so anyway, we're trying to finish this question. We wanted to find pi minus our angle, which was 1.8235, and hitting Shift Enter. There we get it, and that was very easy that time. I'm sorry, my internet dropped, and so I get approximately 1.31809. Now that's my reference angle. Okay, so remember we also wanted pi plus that value, 1.31809, and hit Shift Enter. And so there's my quadrant 3 angle, 4.45968. Now again, Wolfram Alpha is really good, a really good tool to have with that. Okay, so let's go back to our notes, and here I have it. All right, here I have my two angles. Again, let's see, let's summarize them. We have theta equals, or approximately 1.8235. That's my quadrant 2. And approximately 4.45968. So that's quadrant 2, and that's quadrant 3. And those are the solutions to the equation secant theta equals negative 4. Now, obviously, we'd want to put plus 2 pi k if we didn't specify that we're only talking about the first revolution, right? But if we're talking about the first revolution, it's just the two decimal values that we found. Okay, I hope that makes sense. Sorry for the glitchiness earlier. Okay, now I'm going to give you one bonus example. So I know this is exciting for you. So let's call this example 10. We want to solve, let me think, sine squared theta plus, let me think of two things. How about 4 sine theta plus 4 equals 0. And we'll just solve it 0 to 2 pi. Okay, now that looks complicated, but the reason I picked this example is because remember, we were thinking in terms of algebra. If I let y be sine theta, now my equation is actually not that difficult. It's y squared plus 4y plus 4 equals 0. At this point, I'm trying to think two things that multiply to give me 4 and add to give me 4, 2 and 2. And I see now that this is actually, let's change our question a little bit. All right, so we're doing some live engineering here. Let's say 1/4 and 1. Okay, so now we're thinking two things that multiply together to give me 1/4, add to give me positive 1. That's going to be, first we're going to write y squared plus y plus a fourth equals 0. And I got to factor this thing. Two things that multiply to give me 1/4, add to give me 1, 1/2. So I get y plus 1/2 times y plus 1/2 equals 0. So this quadratic, I say it's quadratic because we had a sign squared. This actually just ends up with a solution y equals negative 1/2 or sine theta equals negative 1/2. Okay, so now we think quadrant 1. If I had sine equals positive 1/2, my reference angle, which I'll call theta prime, would be, when does sine equal 1/2? At pi over 6. Okay, so then my quadrant 2 solution, not quadrant 2, when is sine negative? Quadrant 3 and quadrant 4. We got to have solutions for both of those. And we're visualizing here that I have a pi over 6 reference angle in quadrant 3 and pi over 6 reference angle in quadrant 2. So in pi over 3, for quadrant 3, that's going to be pi plus pi over 6, which is 6 pi over 6 plus 1 pi over 6, 7 pi over 6. And for quadrant 4, I have 2 pi minus pi over 6. So that's going to be 12 pi over 6 minus 1 pi over 6, 11 pi over 6. And there are my solutions. Okay, now I just wanted to show that we can, if we let this y equals sine theta thing happen, we can turn what looks like a complicated equation into an algebra equation for which we have plenty of tools to solve for, and then we pop it back into Trig World to solve. Okay, I hope this makes sense. Guys, you're only going to get this through practice, so if you're not practicing, it's going to be very hard. But if you practice, I think you can do it. Just keep working at it, keep looking at it. Let me know if you have questions. I'd be glad to help. Sorry for the internet glitch a little while ago. Just, again, let me know how I can help. Thanks for watching, guys, and I hope you have a great week. See you later.